Good morning. My name is Ren Goodfriend, and I'm a senior at Oak Park and River Forest High School. I am very excited to share with you my research on how cosmic ray muons can cause single-event upsets within microtechnology transistors for specific military and aerospace applications. Muons are subatomic particles that originate from radiation or cosmic rays coming from our Earth's sun and several other space factors. In addition, transistors are the 0 or the 1 in your computer. They are small computer parts. However, when they are affected by muons, they can be flipped from a 0 to a 1 or vice versa. This is called a single event upset. In my research, I decided to create a mathematical model of linear energy transfer, which is a measure of single event upset capability, in order to determine where on Earth muons can cause the most single event upsets. I had two phases. During phase 1, I measured three groups, a negative control, a positive control, and an experimental group, with 1,000, 2,000, and 3,000 trials, to show how muons can cause single event upsets. I had an experimental hypothesis that the energy interference in my actinium-225 group would be greater than the muon group and the lead brick negative control group, respectively. I had an independent variable of detector conditions and a dependent variable of the energy of the detected particles. Once that phase was done, I created a novel Python program to determine the linear energy transfer of all of the particles measured during the 6,000 trials of my experiment.
Testing,
In order to do
testing,
this,
testing.
I
One,
used a
two, three,
measurement
one,
called
two, three.
linear energy transfer, which has been used in several prior studies. As you can see, my results were very exciting. I found that my positive control had the highest mean overall, as shown in figure 3. As seen in figure 5, there was a high mean of the experimental group when excluding zeros. In addition, there was a high mean of the negative control when excluding zeros, showing evidence of muon lead penetration, as the muons measured in this experiment were able to pass through the lead bricks put into place during the negative control. I also included several statistical tests, showing that I could reject my null hypothesis. Finally, in figure 6, you can see the high measurement of the linear energy transfer of muons. This shows evidence that muons can cause significant single-event upsets. The negative control was also high, once again indicating evidence of muon lead penetration. While there were several limitations to my experiment, I expect to continue doing research in how solar phases and altitude can affect muon linear energy transfer. In the future, I would like to create a map of muon measurements all over the world in order to allow aircraft manufacturers and healthcare providers to determine the safest places to fly their aircraft and have people using microtechnological devices live in order to avoid single event upsets caused by muons. Thank you for listening to my presentation. I have a few sources here.